Hello. Today we're going to work on finding the greatest common factor of a set of numbers or expressions. So, let's talk about what each of those words mean, greatest common factor. Now the word factor, a factor is a number or expression used in multiplication to make another number. So for instance, if I take the number, let's say 21, the factors of 21, well, I can list that as 1 and 21, or 3 and 7, so the numbers 1, 3, 7, and 21 are factors of 21 because they can be used in a multiplication problem to make 21. So if I want to find the greatest common factor, that means I'm going to find the largest factor that they share. So the largest shared number that is used to multiply to make them. And so essentially if we're undoing the multiplication that we did to get numbers, we would be doing division. So let's look at our first example. In number 1, we have 18 and 45. So in 18, if I look at the list of numbers that I can use to make 18, so there's 1 and 18, 2 and 9, or 3 and 6. And then for 45, a lot more. There's 1 and 45. 2 doesn't go in, but 3 does. 3 goes in, that's 15 times. 4 doesn't go in because 2 doesn't go in. 5 does go in 9 times, and that's it. So to look at our list, if we were to find the greatest of those, 45 is not shared, it's not in common. 15 is my next biggest, not in common. 9 is my next biggest, and yes, they do match. So the GCF of 8 and 45 is 9. In number 2, we have 6x cubed and 19x to the 4th. Well, 6x cubed can be rewritten as 2 times 3 times x times x times x. 19x to the 4th, 19 is a prime number, so all I can take out of there is 19, and that's x times x times x times x. Notice that they don't share any numbers, but they do share some variables, 3 of the x's. So the GCF of this one is x cubed. Okay, so in number 2, I did a prime factorization of these, meaning I wrote them out as a factor of all the primes. 2 and 3 are prime and 19 is prime. I didn't do that for number 1, so let's combine those styles and see what we can come up with for number 3. Number 3, 18x cubed y squared. 18, if I were to do a prime factorization, I can do a factor tree. I can take a 2 out, and I'm left with 9. And 9, not prime, gives me 3 and 3. So this is 2 times 3 times 3 times x times x times x times y times y. All right, let me cordon that off over there. All right, and then let's do that same thing for the 12. 12, I can take a 2 out, and 6 is not prime, so I can take another 2 out. And so we have our prime factorization there. 12xy to the 4th is 2 times 3 times x times y times y times y times y. So let's see what we have in common here. There's a pair of 2's we have in common, a pair of 3's we have in common, a pair of x's we have in common, a pair of y's there, and a pair of y's there. And so we look across any one of our rows and multiply this up, the things that we have circled. So 2 times 3, that gets me 6. X is by itself, so it's x to the first, and then y is multiplying together 2 of them, so 6x y squared. Now the idea here is that you can look at 18 and 12 and just realize that, oh, 6 is the biggest number that divides into both. Between x cubed and x, the most x's I can take out of it is an x to the first because that's the most that this one has even to offer. And same with the y squareds. I can take a y squared out because that's the most that this one has to offer. And so we are done.